Hello everyone, I'm Indu Joshi. I'm a postdoctoral researcher at INRIA Sophie Antipolis, France. Today I will be presenting one of the research works that I did while I was a PhD student at IIT Delhi Computer Science Department. This work was accepted for oral presentation at IJCNN 2021. The research is titled Data Uncertainty Guided Noise Aware Preprocessing of Fingerprints. Deep models do not specify when a model is expected to generate an erroneous prediction. Uncertainty estimation is a standard technique to introduce transparency in deep models. Generally, uncertainty in a deep model arises because of either uncertainty in parameters of the model, which is termed as model uncertainty, or noise present in the data, which is termed as data uncertainty. Data uncertainty is the uncertainty originating due to noise present in a given input. Factors such as occlusion or sensor noise result in high data uncertainty. Data uncertainty cannot be explained away even in the limit of infinite training data, as it captures the inherent noise in the input. Data uncertainty is formalized as a probability distribution over model output. Given the input fingerprint image, data uncertainty estimation using Bayesian deep learning requires placing a prior distribution over output of the model and calculating the variance of noise in the model output. Predicted data uncertainty, being input dependent, is learned as a function of input image. To obtain both the pre-processed image and its associated uncertainty, network architecture of the baseline fingerprint pre-processing model is modified. So in this example, this is a fingerprint segmentation model, but for the last layer, one more branch is introduced. Apart from predicting segmentation mask, the other branch will be predicting the data uncertainty. The mapping between the input and pre-processed image is learned in a supervised manner. Uncertainty values are learned in an unsupervised manner without needing any labels. The loss function of the baseline architecture is also modified to enable the modified architecture to learn to predict data uncertainty. Fingerprint pre-processing models can be either based on regression or classification. In case of regression, the change in output can be directly calculated. However, in case of classification, in order to capture the true change in output, change in the value of logit is monitored rather than change in output probabilities. So assuming that the loss function is y minus fx, the modified loss function introduces the noise variance term in the denominator of the residual error. So if the residual error is high, in order to minimize this objective function, the predicted noise variance is high. So the predicted data uncertainty is high. But then to regularize the value of the predicted uncertainty, the other term is introduced in the objective function. Similarly, for the classification model, the network is optimized using Monte Carlo integration over cross entropy loss for softmax probabilities of sampled logits. We find that data uncertainty guides noise-aware segmentation. On analyzing the predicted data uncertainty, we find that for noisy and background pixels, we find that the predicted data uncertainty is higher compared to the foreground fingerprint. We compare the data uncertainty for foreground versus background and correctly versus incorrectly classified pixels, and we find that higher uncertainty is predicted for background and incorrectly classified pixels. Thank you for your attention.